Hello guys, welcome to my YouTube channel. Today we are going to learn Laplace transforms. Hope you're ready. Let's get started. The Laplace transform of an expression f of t is denoted by L of f of t and is defined as a semi-infinite integral L of f of t, which is equal to the limit of the integral 0 to infinity, right? The limit 0 to infinity of the integral of f of t e exponent negative xt dt, which is equal to f of x, where our s is greater than 0. But please, let's take note of the table below here. So these are functions, right? Let's go through the table one by one. So if you find the Laplace of a, where a is constant, you're going to get a over s. Meaning if you find the Laplace of any constant, you're going to get that constant over s, right? The Laplace of e exponent at, you're going to get 1 over x minus a. If you find the Laplace of sin at, you're going to get a over x squared plus a squared. If you find the Laplace of cos at, you're going to get s over s squared plus a squared. If you find the Laplace of sinh at, you're going to get a over s squared minus a squared. If you find the Laplace of cos at, you're going to get s over s squared minus a squared. And finally, if you find the Laplace of t exponent n, you're going to get n factorial over x exponent n plus 1. Yes, and if we insert each of the functions here in place of the f of t here, you're going to get the answers by the Laplace here. So this table is in the simplified form, right? Yes. So there are several examples here for us to solve. Now, the first one says you have to find the Laplace of 6. Now, 6 is a constant, right? So the Laplace of a constant is the constant over s. So in this case, the Laplace of 6 is 6 over x. The Laplace of e exponent negative t, from the table you can see that if you want to find the Laplace of e exponent at is 1 over s minus a, right? In this case, our a is negative 1. Okay, so you're going to get 1 over s minus negative 1, right? So 1 over s minus minus 1 give you 1 over x plus 1. And you have to also find the Laplace of e exponent 4t. At this point, our a is 4, right? So you're going to get 1 over x minus 4. The Laplace of cos 10t. Now, if you refer from the table, you can see that the Laplace of cos 80 is s over s squared plus a squared. And in this case, our a is what? Is 10. So you're going to get x over s squared plus 10 squared, which is going to give us x over s squared plus 100. Okay. And the Laplace of sin 2t. Now, the Laplace of sin 80 is a over s squared plus a squared. And in this case, our a is 2. So you're going to get 2 over s squared plus 2 squared, which will give you 2 over s squared plus 4. Okay. And the Laplace of sin 4t. Now, from the table, the Laplace of sin 80, you have to get a over s squared minus a squared. Okay. A over s squared minus a squared. So in this case, our a is 4. So you're going to get 4 over s squared minus what? 4 squared, which is 4 over s squared minus 16. Okay. And finally, you have to find the Laplace of t cube. From the table 2, you can see that the Laplace of t exponent n is n factorial over x exponent n plus 1, where our n is a positive integer. So here our n is 3, right? So you're going to get 3 factorial over x exponent 3 plus 1, which will give you 3 factorial by x exponent 4. And you know that 3 factorial is 6. You're going to get 6 over x exponent 4. So that's all for the examples above. They're very simple, okay? Now, these are some basic properties that we use in Laplace transform, and let's go through it step by step. You have property 1, which is called a constant multiple. It says if A is a constant and f of t is a function of t, then the Laplace of A multiplying the function f of t is equal to A multiplying the Laplace of f of t. So it says that if you are finding the Laplace of a constant, multiply a function, you have to bring the constant out and find the Laplace of what? Of that function. An example is here. The Laplace of 7 sine t, right? What you have to do is just bring the 7 out so that you can find the Laplace of sine t. Okay, yes. And you have the property 2, which is called the linearity property. It says that if A and B are constant, while f of t and g of t are functions, then if I find the Laplace of L of a constant multiplying f of t plus a constant b multiply g of t is the same as, or it is equal to. Now, we also apply the property 1 here. So what you have to do is to bring the constant out, you find the Laplace of the first function, plus you bring the second constant out, and also find the Laplace of the second function. Okay. So an example is here. If you are to find the Laplace of 3t plus 6t squared, what you have to do is to first of all bring the 3 out, find the Laplace of the first function, plus bring the 6 out and find the Laplace of the second function, as we've done it here, right? Good. Now we also have the property 3, which is called the change of scale property. It says that if L of f of t is equal to f of x, then the Laplace of f of at is equal to 1 over a f of x over a. So if I find the Laplace of a function and inside the function there's a constant in it, you have to bring the constant out. But in this case, it will be 1 over the constant f of x over the constant, right? An example is here. Now you have to find the Laplace of f of 90. So in this case, you have to bring our constant 9 out, but it will be 1 over 9 f of x over 9. Yes, hope you understand it. Yes, so in this case, it's 1 over 9 f of x over 9. There's an example for us here to try, okay? And it's very simple. Let's go through step by step. So in this example, you have been given a function, right? And you have to find the Laplace of this function. Don't forget, there are constants in, so you are going to apply the properties that we learned above, right? Okay. So this is the function. So for us to find the Laplace of the function, you have to multiply our L through, right? So that you can really see that you have found the Laplace of the Laplace of this function. So you can see that I've multiplied the L through, right? So the Laplace of f of t is called the Laplace of each of the functions, right? Yes. But applying the property 1 and the property 2 here, now you can see the Laplace of 6e exponent 7t, it contains a constant 6, right? So you're going to bring the 6 out, then find the Laplace of e exponent 7t. The second one is not containing any constant, so we just leave it like that. Okay. Now, when it comes here, this one you apply the property 2. So what you're going to do is we bring the constant here, which is the 5 out. You find the Laplace of this function minus the Laplace of 9, right? Now it's standing here alone, okay, with no function. So we just apply, we just find the Laplace of their constant, okay? Yes. So here you're going to get I think there's a mistake here, okay? Yes. So 6L So 6 the Laplace times the Laplace of e exponent 7t plus the Laplace of e exponent negative 2t plus the Laplace of t squared. And please, here there's no 5 here. I think here there's no 5 here. So plus the Laplace of 9, right? Sorry, minus the Laplace of 9. And from the table or from the example that you saw above, you can see that the Laplace of e exponent 70 or e exponent 80, let's go back to the table. The Laplace of e exponent 80 is 1 over what? S minus a, right? Good. So when you come back here, the Laplace of e exponent 70, in this case, our a is what? Is 7. So you're going to get 6 times. Don't forget, the 6 must multiply everything there, right? It's a constant. So you're going to get 6 times now 1 over x minus 7. That's the Laplace of e exponent 70. Plus, now the Laplace of e exponent negative 2t. In this case, our a is negative 2, right? So you're going to get 1 over s minus minus 2. And this is our a, right? Good. Plus 5 times. Now, the Laplace of t exponent n is n factorial over x exponent n plus 1. And we can also check again from the table. Yes, that's it. So the Laplace of t exponent n is n factorial over s exponent n plus 1. So in this case, our n is what? Is 2, right? So you're going to get 2 factorial over x exponent 2 plus 1. Okay. And the Laplace of 9, don't forget 9 is constant. So the Laplace of a constant is the constant over s, right? The constant over s. So you're going to get 9 over s. Okay. Okay. So if you multiply this by 6, you're going to get 6 over s minus 7. And here, s minus minus to give positive. So you're going to get plus 1 over s plus 2 plus. Now 2 factorial is 2. And x exponent 2 plus will give you x cubed, right? So you're going to get 5 times 2 over s cubed minus 9 over s. So the final answer is 6 over s minus 7 plus 1 over x plus 2. Here I multiply the 5 by 2, which will give you 10, right? Plus 10 over s cubed minus 9 over s. So this is the Laplace of the above problem which we were given. That's the function f of t. Okay. Yes. So there's a trial work here. You can try our hands on it, and you can also send the solution to the comment section so that we verify. Yes. Please don't forget to subscribe. And that's the end of the video. Thank you. Bye bye.